Hello, this is Nam. Hi. I thought I might want to do a quick run through of the thing I wrote yesterday. I could also just turn the traffic off, but I won't. It's a bit dark in here, so let me show you what I mean. These are just a few test objects. I have a working light. It moves about. I can ignite it with the thumbstick in case of touch. I can ignite it and shake it about, and it snuffs out again. And most importantly, I can light candles with it. There we go. And that's just a similar flame reacting in the same way. Even better, I can ignite other candles with that same flame. And even like this. Here we go. Okay. Will you go away? The car is very loud in here. Maybe it's not as loud for you, but I will just keep... Ooh, that it looks nice with the flames in the shadow. Wonderful. I'm using deferred rendering, so adding more lights isn't that much of a problem. It's leading to other problems as well, but I knew I wanted to have more light sources, so I set up the scene as deferred rendering. Anyway, I showed you a bit of the process of getting that flame working while doing it, but it was a bit messy, so I thought maybe I'll walk you through what I ended up doing, and hope that helps and inspires some of you to try the same. So let's get to it. How loud is that? I don't know. So let's see, let me find my glasses. So it all began, let me just start by the start. Well, I won't run through the blocks bit again, which I use blocks to just model these two shapes and use Cinema 4D to add two joints to them and animate those joints so it looks like a flame. I select them both. Well, I'll even select it. So this part is the ignition of the flame. From 60 to 120 is just staying alive of the flame. And from 150 onwards, I snuff it out, just manually animating. Choop choop. Beautiful. So that's just a simple animation. I imported that into, let me see, effects here, small flame, into Cinema 4D, Unity of course, and defined the three animations. So this is the ignite bit, this is the flaming loop, and here's the snuff out loop. Well, it's not a loop, it's a one-time animation, of course. And I added that to my little flame object here. So this is the animated model. Let me show you the animator. It starts out hidden. There is a trigger here. So these two triggers get triggered by script. Trigger ignites makes well, this is an empty hidden state, so we can't preview this here. But if you press ignite, it goes to this animation and then straight into the flaming animation, which is just this bit. Oh, come back. Yes. So ignite. Oh, ignite. Oh yeah, I doubled the speed of the ignite animation, I believe. Yeah, it's pretty quick now. And if you trigger snuff out, you get this, just the flaming animation and the snuff out animation, which you can also do. I had to add another transition from here to here that also got triggered by the snuff out for the rare case that you are snuffing it out while the ignite animation is playing. And then it simply goes back to the hidden state. And the whole flame object here gets hidden. Okay, that's the visual bit. Now the behavioral bit is defined on its parent, also small flame. Small flame controller here has a capsule collider. It's the small one here. The other one is used for something differently. I'll come to that in a bit. I only use this capsule collider for the physics, so that the flame has a bit of a body. I place the whole flame into the no collisions layer here, so it doesn't collide with anything, but it has a physical body. So the rigid body and the joint here acts on it like it should. So I use a configurable joint here on the whole flame object, which includes the animated flame, the lights, and this ignition area I come to in a bit. I connect that simply to the lighter itself. So this object, which is a physical object because, well, we're grabbing that and throwing it around. That configurable joint is set up as locked in translation and free in rotation, but has a tiny bit of slurp drive. So it tries to get to its neutral state with the force I define here. So when the lighter is like that, the joint will try and get the object to point that way a tiny little bit. That's the purely component-based setup. I also, within the script of small flame controller, add a bit of anti-gravity, and that's just a force pulling on the object pointing upwards always. 0.3. So when the lighter is like this, there's a force on the flame object pulling it back up like this. It counteracts the force in the joint here, which is trying to move it back into a straight, pointing straight out of the lighter, and it makes for a nice dynamic balance. So a lot of time was spent tweaking these two values against, well, not a lot of time, against this value. Now to get the motion of that flame when I move the lighter about, because the small flame gets just dragged via the transform, because it's parented to it with the lighter, it doesn't move when you just move it like this. So what I'm doing within the small flame controller is I apply a counter motion force. So should I show code? I'm not sure if I should show code. Let me see. Yeah, I measure the velocity every single fixed frame, and I apply over here. I apply a velocity counter to. I apply a force counter to the velocity that is measured at the world center of mass. And that means that if I move the lighter this way, there will be a force on the flame going this way, but because it's attached by joint, it will result in the force doing this. And that's exactly what you want to do when you drag something around. And then when you keep it still, the anti-gravity force and the slurp force in the joints start acting up it and make it go straight up again. So since I was already measuring the velocity, I also added a snuff out speed to it. And the only thing that does is snuff out, deignites the flame once you move it with a certain speed for a certain amount of time. That's what happens here. So if the speed, I use a relative speed against that snuff out speed, and I use square speeds because of that calculating faster. If it's larger than that speed, the timer starts ticking up, else the timer is ticking down here. And if that timer, which isn't a real timer because it depends on how fast you're moving, so if you're moving very fast, the timer will count up more quickly. But if it does, and it's bigger than the duration you set for it, it will just simply snuff out the flame. And that's what happens here. That's the same thing we were using all the time. For example, when you release the button, this all happens and the flame is gone and animated out and hidden when necessary. So that's the motion. Well, you saw that happen. I could demonstrate it, but there's more to talk through, so I thought let's just continue, I guess. I think that was everything for the flame itself. On the lighter case, I add to the lighter itself, I add this script which I wrote on camera but changed about very much off camera. Just a interactable with input script that starts working as soon as you grab it and stops working as soon as you release it, and it looks at the user input on the controller with which you're grabbing the lighter, checks if you move the thumbstick or the thumb pad on 5 around, and if you do and you press it, it calls this function positive input. You ignite the flame. As soon as you release it, it will call this function negative input and snuff out the flame here. Oh, papa. Yeah. Also implemented its toggle states just to check out, but hold really works best for the lighter. Toggle might be nice for something like a flashlight or something. So, and these just go back to that small flame, igniting it, releasing it when, snuffing it out when the button gets pressed and released. Yeah, I think, there's a small light as well in here. I added a few lists to the flame object. Over here, enable and ignite is a list, disable and ignite is a list, and as soon as the flame gets enabled, the flame light gets enabled, just a game object, which is the thing that lights up a little bit of the room. There's a tiny fluctuate light script on here that just varies the light tiny little bit during runtime. And it also, let me see, it also enables this here, and this is where the magic happens. This is the ignition area, and this gets enabled as soon as the flame is enabled. And this is what drives the flame propagation between flames. It's really, this thing is rather simple. It has a capsule collider on trigger. Because we don't use this for collisions at all, it's just a trigger thing. It has a tiny keep up script that, well, let me just show you what that does. It just keeps the thing upright. If I enable this, I have a visual display in my during play mode. So let me show you how that works. So here we are. I light it, and it just keeps, no matter what the flame is doing, no matter what my lighter is doing, it keeps that area upright. So there's always the heat of the flame, because this is what ignites other pieces, is always in this area here. Okay. Let's disable that again. Kaboom. No, this doesn't do many interesting things, this igniter script here. The only thing it really does is check on trigger enter and on trigger exit. And as soon as it enters a trigger, which has the correct tag, which I define here as a user definable value. Because if it's not the correct tag, it just ignores the whole event. If it has the correct tag, we assume it also has an ignitable script, and then starts the warming process on that ignitable script. And that ignitable is something that's added to the candles. So it's not on the lighter, it's only on the candles. So for example, here is one of my ignitable areas, which is just a box collider and that ignitable script. So as soon as this collider enters this collider, the warming process starts. And what that does, let me check. It was a start warming process here. It remembers which igniter it is, adds it to lists. Well, first it ignores any messages if it's already in flames, which shouldn't happen, but that's just a sanity check. It adds the given igniter, so the one entering its trigger, to a list and starts the particles playing back, so we know we're in ignition mode. Stop warming process is the reverse. Ignore if we're in flames, remove the igniter from the list. If there are no igniters left, we stop the particles. Then this object, this ignitable, simply runs through all the igniters it has in its list. It checks here if they're active and enables, and removes them here if they're not. So ignore this. This is just a bit of a robustness code. Robustness should be an English word. And it simply adds to the heat value, the internal heat value, with the heat parameter found in the igniter. Sorry, in the ignition area here. So this ignition area has a heat of 0.3. Every second, 0.3 gets added to the heat value, and this ignitable heat value, which is over here, within around 3 seconds will run up to 1. So it should ignite in about 3 seconds. If there's no igniters, we run down the heat value, and it seems it runs down slower than it runs up, and this is a hard-coded magic value, which we will ignore. And if the heat reaches 1, it calls do ignition. And do ignition is this function here, and I do deignition, just the reverse of that function. Sanity check, and it starts the events that are defined, does some other stuff here, and those events are what you can define over here. And in this case, that's just selecting the small flame object that belongs to the same candle and calling ignite flame on it. And then the same thing happens all the time. This small flame gets ignited. it will enable its flame light here, it will enable its ignition area here, which is the same thing that also ignited the flame itself. Some other stuff gets disabled. Right, I disable this as soon as the small flame here gets ignited. I disable the ignitable area here, because once it's ignited we don't have to check for anything anymore. And if we didn't do that, it could probably keep igniting itself over and over again, which would just be code running and running and running, not accomplishing anything. So I simply disable the ignitable area. I think that's about all it does. Let me have a quick check if I'm getting something. No. Ignitable. Yeah, well, it has the feedback particles here as child. That's just a particle system that does this, that gets fed the heat parameter times the emission multiplier. So the warmer the fuse, the wick here gets, the more particles will start sprouting. And this, well, is just for the feedback to the player that something is happening, of course. Yeah, that's about it. So that's how I set it up. I hope this has been helpful, inspirational, or something. I think it works excellently, and I'm now off to try and make it work on other things like the gas stove over here, and maybe, well, I wonder what happens if you try and light the toilet paper roll here. And I of course have a gas stove over here that also could do with an ignition area leading to other results. I have matches. So, much fun to be had still. Okay, hope you enjoyed. See you again later. Later.